All right. So we have two pieces. We have a negative line. We have a positive line. They are meeting up at the origin of 0, 0, right? Looking at this, what's my domain of this function?
-3.
It's all of them. Your domain is all reals. Because domain is at my x or my y? Domain is my x. We're forever going to the left, forever going to the right. All right, how about my range, though? Yes. My range is 0 to infinity. Because your y's, they stop, don't they, at a certain part? This is as low as your y's are going to get. And that's at a y of 0. And they're all above it. So when I do bit 0 to infinity, does 0 get a bracket? Yes or no?
No.
Yes, this time it does get a bracket. Remember, you could also do our fancy R. Here, we can also do greater than or equal to 0. It means the same thing. All right. Where is my function increasing? Is it the first half or second half?
Second half.
The second half. This piece is increasing, right? So where is that happening?
1.
No, where is it? 0 to infinity. And where is it decreasing?
From negative infinity.
Yes, good. Why don't we have brackets here? Because 0 is on the graph. Why can't I put 0 on there with the bracket?
Because it's not, is it not, like, is it an open circle?
No, it's a closed circle. It's not moving, right? Increase and decrease is talking about movement. We don't move at a point.
Oh, you don't, on these you don't put brackets.
Correct. Increasing and decreasing will never have a bracket. When you're driving your car, so we're all starting to do that now, okay? When we go from forward to reverse or reverse to forward, your car has to stop, right? That's when you're not moving anymore. So when I'm going from increasing to decreasing or vice versa, it stops. There's no movement at that point. How about evaluating? So,
That's -3 equals, or 3.
okay, so we are looking at the x of -3. We're seeing where on the function does that fall, and it falls right here, which is a +3. Then it asks me for an x value of +3. That falls on my function, also at 3. So a little bit of a review of our piecewise functions. How to graph them, how to answer questions on them. Any questions about your warm-up?
No.
Okay. So we are not going to spend the day doing word problems. I will probably show you one tomorrow, just so we can say that we did it. But tomorrow it's going to be used more as a review day for you guys. So that means there will not be a word problem on your quiz. Okay? But we'll do one together so we can say we did it, you've seen it. Okay? I don't have to assess you on it, but I do have to show it to you. So I'll show you one tomorrow. We'll move on, we'll review. Quiz is Friday still on all of our piecewise functions. I will not put a word problem on there. Maybe a bonus, haven't decided yet. Okay? And as always, you get to make your cheat sheet for that quiz. So we're moving on today to absolute value functions. Okay? You're like, how does this fit? You will see. Do you remember absolute value?
Yes.
What does that mean?
It's the absolute value of the number.
Okay, but what does that mean?
Distance from 0.
It is your distance from 0. Perfect. It is the distance from 0. Good. Because the result of my absolute value is always a what kind of a number? Positive, because we're not going to do negative distance, right? So absolute value is a distance from 0. So the absolute value of -3 is 3. How about -2? -1. 0. 2.
What?
Tricked you, didn't I?
It's just the distance.
It is just my distance. Okay. So my absolute value graph.
It feels like, in like a...
Wait, was that not our warm up?
Was it?
Was it? Okay.
I think today just made a connection. That's what just happened. Yes. It looks familiar. A little bit of deja vu going on here?
I
Does it look like something you might have just done?
It's not that bad.
I did that one first.
All right. So absolute value, so we always have positive numbers out of it. How could my absolute value maybe be an upside down B? If there was a negative out front of it, so like a reflection going on. Remember that stuff? Okay, we'll get more into it in a second. So looking at this absolute value, if I wanted you to write the piecewise function of it, do you agree that this is made of two different pieces?
Yes.
Yeah? What's this first piece? It's A. What's the equation of line A?
X, it's negative X.
Negative X. When do you see it?
X plus 0.
Oh, it's coming back. What about line B over here?
X.
Just X. When do you see it?
X is greater than.
Yes, so this is the same thing that we just did. So more deja vu. What's the domain of this absolute value? All real numbers. What's my range? 0 to infinity. Good. This is a new question. What is my x-intercept? 0, 0. So remember, an intercept is a point. Okay. What about my y-intercept? 0, 0. Yes, ma'am.
Can I stay right there?
Yes. What about our relative minimum? Good. How did it know it was a minimum?
Because that's the minimum.
What makes it a minimum? Why? How come it's not a maximum?
Because it's the lowest point.
It's my lowest point. Good. So what would make it have a maximum?
Infinity.
If it got reflected, if there was a negative out front and that flipped it over. All right. Another new question. What is my axis of symmetry? Just 0? Is it an axis, a line?
0, 0.
It's a line, right? That's not a very straight line. An axis of symmetry is a line that cuts it in half. So Emmy told me it is x equals 0. Someone else said it too, but she said this is x equals 0.
Oh, it goes like the other way when you want.
Yeah. Good. So looks a little bit familiar, doesn't it? So some fun information. You got this? This is not on your paper. This is not on your paper. So this special piecewise function is called an absolute value, which has those bars, right? We remembered it. It does have a maximum or a minimum. So this guy has a minimum, right? I'm at the very, very bottom. Whoop. But how would it, whoa now. How would it have a maximum? How would this have a maximum? If it was flipped upside down. Now it has a maximum point, right? So minimum is if my absolute value is not reflected. A maximum is if it becomes reflected. All right. I pushed lots of buttons, didn't I? Is this the next one? Okay. Well, I'll just stay here. All right. Consider the following graph of an absolute value function. So we also just discovered absolute values are piecewise. There are two different pieces, two different lines. So let's write the absolute value function of this one first. So what's the equation over here of line A?
Negative x plus 3.
Yeah, negative x because we're going down 1 over 1 as my slope. Plus 3 because I can see that's where it crosses my y-intercept. Where do you see it? X is less than or equal to 3. Good. All right, my second line, line B over here.
No, you have to go down. 1, 2, and x minus 3.
Okay. So do you understand what he just did out loud?
No.
Okay, so we see it's a positive x as a slope, right? What I don't see is where B is crossing the y-intercept because that's the piece that got cut off. So if I extended my line down, following that same slope, I can see where it would have crossed, which is at -3. Okay? Remember, the equation is for the entire function, the entire line. Okay? The domain tells you what piece of that line you can actually see. So here it's y when x is greater than 3. Okay, so I have a piecewise function of the pieces separately. The absolute value function is all of it put together. So looking at my absolute value functions, I have inside of my bars x plus 3 and x minus 3. Which one of those do you think it's going to be equal to? Okay, why do y'all want to say minus 3?
Because.
What did the vertex do?
Yeah. What's the vertex again?
It's that point. This guy right here.
Oh. So,
And it goes down to -3.
Do we agree that the vertex got shifted to the right 3?
It's a transition.
Yes. So, because it got moved to the right 3, that means inside with my x will be a minus 3, right? This one moved to the right, this one moved to the left.
Oh, shoot.
Just like our parabolas, right? If I had this as a parabola, didn't my parabola move to the right or move to the left 3? Okay. So don't think, oh, because it's absolute value. Nope, has nothing to do with the actual function. It has to do with being added or subtracted inside with the x. All right, so the correct equation is the second one. So we talked about the vertex. What is it? Where is it?
3.
0.
Thank you. It's a point. 3, 0.
Oh, yeah.
Oh. That should be a positive 3. 3, 0.
Are you good?
Are y'all good? Y'all okay? You were just being a concerned friend.
You said he was eating his neck?
Hitting.
Oh.
Same graph. What's my domain here?
Yes, that.
Yes, all real numbers. Good.
I can get that right over place.
On absolute value functions, guess what? That's always going to happen.
You know what?
Wait. On what? On what one?
Absolute value functions, when you get the V, your domain is always all real.
Well, you could.
0. Range. Remember, range is talking about my y's. Yeah. So we see where it's sitting. It's no, because that's not a y of 3. This is a y of 3. Is that where my vertex is sitting? Nope. Remember, range is talking about my y value. All of the y's are above my y value of 0. Right? This is the point 3, 0. You can also say y's are greater than or equal to 0. Alright, what is...
I'm good.
Okay, what is my x-intercept if I have one?
Yeah.
Good, 3, 0. What's my y-intercept if I have one?
Negative of 3.
Wait,
No, okay.
never mind.
0,
Our y-intercept is here, which is 0, 3.
I'm looking at the other one.
I knew that.
This is our x-intercept. This is our y-intercept. X equals shows you a line. And intercept is a point. You gotta have the xy points. We good?
Yeah.
Questions?
How do you, for the, I'm out of the brain, but for the piecewise function,
Yeah?
how do you know if it's greater or less than, equal to, or greater than?
You're looking on what side of the graph it's on. So you see where that vertex is? That x value? So like this one, this is the x value of 3.
Mm-hmm.
This first piece only exists if your x values are less than 3.
Since it's on, yeah. If it's on the left side, it's that.
Mm-hmm.
Okay.
And right side would be greater than.
Makes sense.
Okay. All right, new one. Here's a new one. Let's write our equation first. We got 2 pieces, don't we?
1.
Hold on. We have 2 pieces, right?
Yes.
Slope of my first one.
Negative
I'm going to go with, I'm going to call them people. I am. I'm doing it. I'm going to go with Lee. All right, slope of my first one is negative x. Beautiful. Jimmy, what's the y-intercept of the first one? 1. So Emily, that makes my equation what? If my slope was negative x, my y-intercept was 1. What's the? Yes, negative x plus 1. Taylor, where do I see it? No, where do I see line A? Less than or equal to 0. Beautiful. Good. Because it got cut off right here.
I thought it was 1. Is this the 0? Is the x?
Domain are your x's, guys. Domains are your x's.
I'm going to get that wrong.
Yeah, they're all my.
If you plug 0 into that, what do you get out of it? You get a 1, right? So that's why. All right, my next one, I'm going to go to Aaron. What's the slope of line B?
X.
All right, Langston, what is the y-intercept of line B?
1.
So Kaylee put it all together. X plus 1. Good. Jake, where do we see it?
X is greater than 0.
Beautiful. Good. Anna, which one of the absolute value functions represents what we see here? The minus 1 on the outside or the plus 1 on the outside? The plus 1 on the outside. Good. I'm going to ask Brayden, why?
Probably because it's right there.
X absolute value.
Mm-hmm.
So, yeah. And then you just add 1 to it, so it makes it 1 more than X.
What?
Jacob, help him out a little bit. Yeah, you.
Oh. Because when you absolute value it, it becomes positive and the 1. Yeah. Like, when you add 1 on, it shifts it up.
There we go. Yes, you were both trying to say it. It was just a little bit cloudy. Yes, it got shifted up. Because of the plus 1 on the outside of my absolute value, it did get shifted up 1 unit. Good. So that makes my vertex what, Savannah? 0, 1. Good. It's not a question, but max or min? It's a minimum.
It's 0.
I said, is it a max or a min? It's a min.
0, 1.
Yep. Okay, moving on. All right. Griffin, where are we increasing? Okay, don't look at your y. There you go. Look at your x. We're going down until we stop here, and then we go up. So it's from 0 to infinity. Good. Other Jacob, where are we decreasing? Negative infinity to 0. Good. Alex, how come we're not equal to 0 on any of these?
Because I'm not sure, to be honest.
Okay.
I don't get the answer.
Lee, what do you think?
Because it's not moving.
Because we're not moving at 0. So increase and decrease. Where is my graph moving down? Where is my graph moving up? So my graph is increasing, which means moving up from an x value of 0 I keep going over here. That's going to go to a x value of infinity.
Okay, wait, you said, okay, so that means like, if it was on like 5 or something, it's still coming from 0, we wouldn't put 5?
It all depends on what the x value is. It's where the x is. I think the next one will help answer that question.
Okay.
Yeah, so don't lose it. Put a little bookmark on that.
Okay.
I think the next one's going to help you. Miss Allen, what is my x-intercept?
Would it be 1, 0? No.
What's my x-intercept? It's kind of a trick question.
There is no x-intercept.
Is there?
I know.
There's not.
No, okay, so if I kept drawing the lines, there would be, but since my domain made me cut them off, there's not. So on the absolute function, we don't have any x-intercepts. Sorry, I tricked you. Colin, what's my y-intercept?
Or 0.
There you go, 0, 1. Good. Something else that will always happen on absolute values, you will always have a y-intercept. And always, and y-intercepts will always happen. You'll always have one. It'll change, but you will always have a y-intercept. You might sometimes not have an x-intercept, because what happened here to make the x-intercept not there anymore?
There is no intersection.
Why?
Because you can't, it's not on the table.
Why?
Because that's how it works.
What? Look at the actual piece. What did it do?
It stopped and went back up.
The whole thing got shifted up, right? The whole thing got shifted up, so it's no longer touching my x-axis.
It transitioned.
Yes.
Transformation.
Transformed, translation, all that good stuff. Yep. Up 1 unit.
Yay.
Yay, your turn. You can do it. Do the piecewise functions, so do it for piece A and piece B. And then circle which absolute function is going to go with it. All right, so let's look at it. I'm hearing good conversations. Line A. Okay? The equation of line A, which is our first guy over here. Whoop. You don't have to. When I'm talking about it out loud, I like you to know which one I'm talking about. You don't have to put A and B. Line A, it's a negative slope, right? It's a negative something because we're falling down. It's a negative what? Negative x. Good. It does not show me where it crosses, but if I continued that slope of negative x, where would it have crossed? It would have crossed at negative 3. So your first equation should have been negative x minus 3. Okay? The domain is where do you see it? I see this line stop being graphed right here. That is at an x value of negative 2. So all of your x's, domain is x's, all your x's are less than or equal to negative 2.
So I am.
All right, my other side, that's a positive slope now. It's a positive what? Positive 1x. This shows me where it crosses. It's going to be at plus 1. So we have x plus 1. Remember we said these always have a y-intercept, right? So one of your lines, you will always be able to see where it's crossing. The other one, you got to get creative. Where is this happening? When x's are greater than negative 2. Yes. Yes, it is the vertex. Good. Good connection. That's where you should be looking at. Okay. So because of the vertex, which one of these is going to be my equation? Jimmy. I'm going to Jimmy. The first one, why? Good, because it moved to the left 2 and down 1. Now the other equation also had left and down, but it had left 1 and down 2. It had them flip-flopped. Okay? So our vertex, remember, it started at 0, 0. It got shifted to the left 2 and then down 1. So that's why this first one is our answer. Okay? It doesn't ask you this, but what is the actual vertex?
Negative 2, 0.
Negative, it is not negative 2, 0.
I mean, my
Don't
bad.
you give me false information.
Negative 2, negative 1.
Negative 2, negative 1.
Sorry.
So it's okay. To answer the next question. So how does the actual point -2, -1 transform into the equation? What did the x value do? It went from -2 to +2, right? When we put our x's back into our equation, they should always change their sign. Isn't that true for anything?
Yes.
Yes, it is. My y value did -1 change? No. So when you put your x coordinate at the vertex, you should always have the opposite sign when you plug it in or take it out. The y coordinate always stays the same. What is my line of symmetry? What line is cutting it in half? Good. X equals -2. And what piece of the vertex is that? Someone just said it. It's the x. Yes. Our axis of symmetry should always match the x of the vertex. What is my range? Negative, is it -2 or -1? -1. Yep, because we're looking at the y's. Range is y. So we're looking at the y value of -1, and everything else is on top of it. So -1 to infinity. You could also say y's are greater than or equal to -1. All right, questions? For sure? Okay.